In today's video, we will explore what is DevSecOps and why traditional security is no longer viable in application security development. We will discuss how to build DevSecOps frameworks in Agile organizations' secure software development lifecycle. We will explore how we get organization buy-in, how do we use data principles, how do we leverage threat modeling, how do we leverage risk, and the tooling to help us to move towards DevSecOps frameworks in our organization, and how to best leverage it to making sure that we build secure code and prevent any vulnerabilities in our code. So I wanted to explore this, and I took the framework that I've used in previous organizations, and it's a framework that's been used all over the world, and some of the biggest organizations such as AWS, Netflix, and organizations alike use very similar framework to that I'm going to be exploring today with you guys. So firstly, let's jump straight into it. So what is DevSecOps? So for short, it's three words that they've been brought together. So development, security, and operations. Essentially, it's a development practice that integrates security at every stage of software development lifecycle. It's about adding security in agile DevOps practice. And I think the main reason for the rise of that and the building of DevSecOps is, if we look at traditional waterfall developments, we used to have projects that used to take 3, 4, 6, maybe even 12 months. So it was very easy to build security in waterfall development methods because we used to ship code at the end of this project. So after 6 months, there was enough time for security to add their requirements in the waterfall methods. But as we move towards Agile DevOps, most organizations are moving towards shipping and deploying their code into production weekly, sometimes even daily, sometimes even numerous amounts of time during the day. So traditional security practices are no longer viable. So it's about shared responsibility. It's about building culture, automation, and platform design. It's about cultural shift in agile world, including security from the start instead of the close to production line. So it's a whole shift and mindset and building the security culture in our organization. And I see a lot of organizations struggle with that because DevSecOps is not something that you can accomplish overnight. It's a process that takes time, it takes dedication, it takes top-down organization support, it takes skills to get the program into a good place where we can start getting the benefits of the actual practice. So essentially, DevSecOps is a practice where we shifting the responsibility and we allowing developers a bit more autonomy, but we inbuild security requirements in that autonomy. So I always have problem with some of the organizations because the goal is developers are always keen to innovate and ship new code. And we as security, we are used to saying no to developers and creating cumbersome security requirements. So this is all about creating a collaborative culture and how we can, as security, go towards development and embed into their tooling. You know, the one key aspect I always say to security professionals is we can't take developers with us on our journey. We need to go to the development and help them and guide them on security best practices, how they can build a more secure code. And essentially, my main goal is that quality is part of security. So for us to ship a quality code, security has to be built in, has to be designed into that code. So that's how we can leverage the DevSecOps practices. The DevSecOps approach brings with it specific benefits. So first of all, enhanced security application. DevSecOps embeds a proactive approach to mitigate cybersecurity threats early in the development lifecycle. This means that development teams will rely on automated security tools to test the code on the fly, performing security audits without slowing development life cycles. DevOps teams will review, audit, test, scan, and debug code at various stages of the development process to ensure the application is passing critical security checkpoints. When security vulnerabilities are exposed, application security and development teams will work collaboratively on solutions at the code level to address the problem. Secondly, cross-team ownership. So the DevSecOps brings development teams and application security teams together early in the development process, building a collaborative cross-team approach, rather than siloed, disparate operations that stifle innovation and even lead to division among business units. The DevSecOps empowers teams to get on the same page early, leading to cross-team buy-in and more efficient team collaboration. Also, it allows to streamline application delivery. We can embed security earlier and often in the development lifecycle, automate as many security processes as possible, and streamline reporting, all enhance security and enables compliance teams, ensuring that security practices embolden fast development cycles. For example, suppose a development team completes all the initial development stages of an application only to find that there is an array of security vulnerabilities right before bringing the application to production. In that case, this results in a major delay in delivery. So we want to avoid that. We also can limit security vulnerabilities. So we can leverage automation to identify, manage, and patch common vulnerabilities and exposures. Use pre-built scanning solution early and often to scan any pre-built container images in a build pipeline for CVEs. Introduce security measures that not only mitigate risk, but also provide insight to teams so that teams can remediate quickly when vulnerabilities are discovered. One of the strongest benefits of DevSecOps is that it creates a streamlined, agile development process, an approach that, if done correctly, can greatly limit security vulnerabilities. Many of the cybersecurity testing processes, tasks, and services integrate quite easily with the automated services found in application development or operation teams. So by emphasizing security-first approach to the development process, organizations can remove unknown variables that will undoubtedly influence that product release and timelines. So it brings a host of benefits to agile development teams to scale and remove any security vulnerabilities from the code, as well as to streamline the speed how we deliver code to production. So there's a host of great benefits in that case. So where do we start? First and foremost, I think the most important part of it is getting top-down support and budget allocation. What do we mean by that? So essentially, we need senior leadership support to get the program underway. We will need budget, and the budget does not necessarily mean that it has to be big spend to get the program off the ground, but we will definitely need support in building the rest of the requirements in our DevSecOps framework. So getting support, getting leadership to support our program, identifying the benefits that we mentioned, identifying how we will ship the quality code, and the benefits for the organization of creating DevSecOps program as we move forward will be a tremendous help. So once we're getting the top-down support, we will need to identify and assign security champions networks within our development teams. And that's where things like budget might help us, because as you look at traditional development work, developers are normally just innovating and building code to ship to the production. But when we assign security champions, obviously that will create extra responsibilities for them to making sure that they complete threat modeling, they identify security best practices in various coding teams. So I'm always been a fan to create a security champions network where we create a collaborative approach where we reward our security champions. So whether it's a bonus, a salary increase for being a security champion, and to get the most benefit out of Security Champions Network, I've always been a fan of creating sort of reward program where we send our security champions to specific security conferences where they can upskill, where we potentially can provide even additional training on things like OWASP, top 10, give them specific tools where they can enhance their security knowledge. There is great security platforms that allow to enhance their skills. I mentioned security conferences, something like Black Hat, RSA conferences are great ways to upskill your developers and learn about what's happening with the current threat actors, what kind of vulnerabilities they are discovering, what's the newest in the threat world. And that's a great way to enhance their skills, but as well as reward them for their hard work. Now, thirdly, another very important part of the program, we need to add an AppSec expertise in our information security teams. And I'm always follow the framework, and I think it works really well, because the way we will do application review, and I will cover that in the next slides, but we create a framework where 3 development teams have one assigned AppSec engineer or DevSecOps engineer, however we call that position in our InfoSec team. But essentially, it's an escalation point where security champions can escalate to an AppSec professional and get help while rectifying their threat model, enhancing security best practices in their code, and essentially creating better quality code. The next stage is we also need to draft KPIs for our development teams and overall project success. So what do I mean by drafting KPIs? So key performance indicators. As I mentioned before, I view security as a quality benefit. So drafting those KPIs and including things like limited vulnerabilities, exploitation of code, that's a key KPIs that we can add and how we build a quality code. Another big part is, as we move and scale our security in DevSecOps, it becomes very important to create reusable security standards. And what do I mean by that? So in development, normally, especially when we move towards Kubernetes or microservices architecture, the goal is to not reinvent the wheel. So if we are building authorization, identity frameworks, the best goal is to use what's already out there, the frameworks that has been tested by time, and we can embed them in our code. So the goal is to draft, for example, something like even container images. We can draft security approved container images library where developers, without asking security, they can use those images that are already security approved to build their containers. We can create authentication flows that can be reusable into their code development. We're essentially building blocks of code that are already security verified, security approved, where developers can leverage that to build a better quality code. And lastly, and one of the probably the most important ones as well, is developing a training program for developers for threat modeling, security best practices, as well as risk. So as we mentioned, once we shift the responsibility, we need to train and get developers to understand how we measure risk, how to do a threat model, how to identify potential threats in a threat model, and how to build mitigations for those particular threats in our threat model. So we can launch something like lunch and learn programs, we can leverage tooling, we can leverage knowledge sharing sessions, which are great for developers to upskill and understand how we can leverage security best practices. So as you can see, the image depicts how we shift and change our target operating model. As you can see, this image is taken from AWS AppSec team, but essentially most organizations will do a similar shift in target operating model and how we essentially allow more autonomy to our development teams through security champions networks, as well as in additional training. So as you can see on the left, development teams normally they only been responsible for their tasks. The stories, features, and epics normally have been handled by an application security team, which is part of the information security team. So the goal is to go from the left pyramid to the right and give development teams more responsibility and more ownership of their tasks, of their stories, as well as of their features. So only the epics where application security gets really involved. Teach them secure coding practices, as well as teaching them threat modeling techniques, and as well we will embed security automation tooling in our continuous integration and continuous delivery pipelines. This way we allow developers more autonomy and essentially increasing velocity and speed in code delivery. Because developers no longer have to wait for specific security approvals. They can make their own decisions as long as they meet the security bar requirements. And we will explore what is security bar in the next slide. But this is how we can create speed and agility in our development teams and ship code faster and essentially give business quicker returns on their investment while building security in the design stage and allowing developers autonomy to leverage the skills that we embed into their teams, and as well as, adding security at design stage. So let's explore what is the security bar. So we needed to set a standard security, which is the minimum we will allow something to be shipped, as in code shipped to production. This is called the security bar. So information security team has a security bar which it maintains. So it's autonomous security standard, and normally we set the bar as high as possible. We have expectation at minimum to meet the security bar. So when developers are designing any feature, they're performing any security review or operating a system, they must assess the product, the feature, or the service against the combined security bar. So how do we build this combined security bar? So essentially what we do, we take information security bar, and plus we add any regulatory or compliance requirements, such as, depends on where your organization is operating. If you take in, for example, credit card payments, you might need to comply with the PCI DSS requirements. If you work in a financial industry, you might need to comply with something like Financial Conduct Authority. If you're dealing with health organizations, you might need to comply with HIPAA. Or if you work with US government, you might need to comply with FedRAMP. So what we do is we take information security bar and we add any regulatory requirements as those mentioned, and this becomes the security bar. So all of these requirements are built in the security bar, which is a minimum bar that development teams need to comply with to ship the code into production. So that's what builds the combined security bar. Together with the security bar, I also always like to develop a specific number of statements, which is named Developer Security Manifesto, essentially statements that developers have to live by. So it starts with developer, you own your own feature, service, security. No one else will own it for you. You should reduce the likelihood of any risk where it is appropriate and proportionate to do so. You should also reduce the impact of any risk where it is appropriate and proportionate to do so. You should ensure we meet our service obligations by producing data and matrix. You should meet our customer security expectations. You should have unit and integration tests which show all mitigations are tested. That's the key part. We should always test the specific mitigations that we developed during our threat modeling exercises. They should always protect the reputation of the company. They should all ensure we meet our contractual obligations such as data jurisdiction and access. You should protect the customer's trust and confidence in the company at all times. They should also remediate all issues in a timely manner. That's why normally we will build SLAs in specific issues that are raised. So what's the time scale when they should be fixed? They should also patch all systems as quickly as possible. They should also ensure that our environment stays compliant to all our compliance regimes. They should also continually improve security no matter where it is today. Always seek improvement and continuous improvement. They should also automate all security activities wherever possible. And lastly, they should automate all compliance activities wherever it is possible. Next, we will assess what is the review process for shipping the code. So first and foremost, when they have a specific project, developers should define security requirements. And one of the most important bits is they need to open the security ticket. So we need to create a specific ticketing system. Normally, developers will leverage something like Jira or whatever other ticketing system that you would use in your organization, and they have to open a security ticket. Then they move into their teams to build an initial threat model, and then they have to assign a security champion. Then they will have a kickoff meeting with the security champion where they can refine the threat model with the champion. So, and as you can see, this is an iterative process that we can go again and again to refine the threat model to make sure that the threat model and mitigations that been found are essentially meet the security bar. So the key point is to follow the security bar guidance, build a threat model, and assign security champion. Ideally, we want to assign security champion from another team because we never want our developers to mark their own work. So when we prepare for the security champion meeting, they have to have ready architecture diagram, threats and threat actors you might be aware, and the high value assets specific and also specific compliance requirements. So as you can see, we essentially, what we do is we allow developers to define their own security requirements. They can open security ticket, obviously, if it needs an escalation. They build their own threat model, assign security champion. Then obviously we have a meeting with the security champion, and then with security champion, they can refine the threat model. And as you can see, once the threat model is finalized and the bar has been raised and met, we have a pre-agreed process that code can be shipped. Now, as you can see, there is a few break lines where code can be shipped if the threat model has been finalized and bar has been met and raised to a specific high standard. If the threats and the risk exceeds the security bar and that stage, then we follow the escalation process. We assign information security, essentially InfoSec, AppSec expert, and then we refine the threat model again with an information security team. So again, that's an iterative process where we can refine the threat model with the information security team. Then we finalize the threat model with agreed security bar. Now, in the last stages, as you can see, we look after that final refinement period with the information security. If the threat and risk still exceeds the security bar, we qualify the company penetration test criteria and we quantify whether we will need a penetration test. So therefore, that's the key point of where we need to open security ticket and inform information security team how the process is happening and whether we potentially might need a penetration test, because normally penetration test is not something that information security team can do with a very short notice. So having them enough notice and see where the risks lies, we can escalate that to information security team and create a penetration test criteria and essentially assign a penetration test if it will be needed in our review process. So that's essentially the framework for review and code shipping practice. How do we meet security bar through threat modeling and assessing the risks? How do we build, architecture diagrams? Data flow diagrams will be a crucial part in our threat modeling. And that's how we move forward. So as I mentioned a few times, threat modeling will be a key part of the exercise during the build of the code and designing our code essentially to meet the security bar requirements. There's various threat modeling frameworks that organizations can leverage, such as one of the ones is an example, Stride. We have Pasta, we have VAST, we have Trike, CVSS, and many others. I will just explore Stride because I think this is the most popular threat modeling framework. So essentially, as you can see, Stride is built up of specific threats and specific properties that can be violated, and what's the threat definition. So as you can see in the image here, Stride is essentially number of threats. So S stands for spoofing identity, and the property that can be violated is authentication. So it's essentially someone pretending to be someone or something other than yourself. The next one, the T, stands for tampering with data. So it violates the integrity property. So it's modifying something on a disk, on a network, memory, or elsewhere. R stands for repudiation. So essentially the property is non-repudiation. So non-repudiation essentially it's claiming something that you didn't do or were not responsible, can be honest or false. I stands for information disclosure. So the property that it violates is confidentiality. So providing information to someone that is not authorized to access it. D is for denial of service. So obviously the property will be availability. So exhausting resources needed to provide service. So something like denial of service attack. And lastly, elevation of privilege. So the property is authorization. Essentially, it's allowing someone to do something they are not authorized to do. So let's dive straight into it, and I'll share you guys an example of a specific threat model. So when you're building a threat model, so this is an example of a Moodle application. So it's essentially a learning management system. It's an application that most of universities nowadays use. So this is a Moodle application. How do we do and build a data flow diagram? And essentially this diagram, the tool that has been used to build this data flow diagram is Microsoft threat modeling tool. So essentially the goal is to build all of the flows and all of the boundaries and all of the services that make up our application. So as you can see, the user on the top left can send a request to the browser client, and then the browser client can send a response. So we have a request and response. So these are the two actions. Then the browser client will access the service request. So as you can see, that's where we build the boundary, because we have a security boundaries that we have to define and look at the potential threats. So user and browser client, that's on the user side. When we go towards the access request service, we break that boundary. So we add the red dotted line, which essentially covers user and web server boundary. So the browser client can send an HTTP access request, and then the access service request essentially can send us an HTTP response. So that's the flow currently. Then, as you can see, the access request service has a few paths that they can go to. They can go to the grade service, where we can send a grade request and then grade response. We also have courses service, where we can get a course request and course response. Then also we have an authorization provider. So again, we can get authorization, we can send authentication credentials and get authentication response. And we also have a role service, essentially, where authorization provider will send a user role request, and then we'll get a user role response. And then lastly, we have a MySQL database that will get a data request, a data response. So that's another that's again a boundary between the web server and the database. So we have essentially three big components. We have a web server, we have a user, and we have a database. And then obviously we have two boundaries. So we have a user web server boundary, and then we have a web server database boundary. So essentially on each boundary, we need to qualify what are the potential threats, how these threats can be exploited, and then we need to essentially, once we design, so this is the data flow diagram, once we go to the next design stage, we will quantify the threats and we will assign mitigations based on those threats. So how does that look like? So if we jump into the next slide, once we completed this trial of the Moodle application, we follow the STRIDE methodology. So we have spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. So what are particular threats? So user can be spoofed via credential theft. That's one of the ones. And then obviously we added here CVSS values as well as the base score. So we have a base score of 5.5, which is a medium threat. User can also be spoofed by database compromise. That's a 4.6, and again, it's a medium threat. Now, going to tampering, data tampering from web server to database. So again, it's a 6.1, it's a low medium threat. Also, there's a potential for data tampering using SQL injection from user browser to web server. So it depends how you build, but obviously user can potentially exploit SQL injection attacks from the user browser to the web server. Now, repudiation. So database may not write data sent to it. So again, that's a medium threat. Browser clients may claim no response was sent to it. So that's the two threats in our repudiation. Information disclosure. So improper limit of responses to queries, which raises a medium threat. There's a potential for data sniffing by a man-in-the-middle attack. And then last two of the ones, so denial of service. So there's a potential for external user overwhelming the web server traffic. There's also a potential for a tracker trying to overwhelm the data store by writing more data to it. And then lastly, elevation of privilege. So modifying the restricted data, as well as access request modification to return higher rows. So these are essentially the threats. And then based on specific threats, during the design and threat modeling, we will start and build mitigations for it. So for example, things like, information denial of service. So how do we limit user for overwhelming the web server with traffic? So we can build essentially denial of service preventions and how we can limit the specific traffic. How we can limit from modifying the restricted data, so building the correct authorization flows and allowing specific users only specific roles, so limiting potential access requests in the journey. How we can limit the user being spoofed via credential theft again, so we can potentially build something like multi-factor authentication. We can limit access requests. We can limit how many times user can enter their password, how we can potentially limit the spoof by, database compromise. All of these threats needs to be discussed at the design stage and build essentially mitigations for them. And that's how we refine the threat model until we have mitigations that are in line with our security bar to make sure that we comply with it, and then we can ship the code to our production. Another important part of our DevSecOps framework build is building a data principles and understanding between the development teams. So the key three principles that we share with our development teams and inbuilt in our framework are transparency, fairness, and respect. So essentially it's an extension to our developer security manifesto and how we deal with data. So first and foremost, in the transparency, we need to make sure that we earn trust. So we clearly and openly describe the data we hold and how we process it. So I'm sure most of you guys are aware of it by now, but data privacy requirements are getting more and more robust. So if we collect specific data from our customers, we have to create a data privacy statements on our website, and we have to clearly and openly describe the data that we hold and the data that we collect from our customers. We also will never be in a position where we are unable or unwilling to share data we hold or process on behalf of or for our customers. Whenever possible, data should remain within customer accounts with which it is associated and be visible to the customer. So for example, if customer authenticates, the specific data that we hold around this customer in their accounts should be visible to that customer. Customer obsession. We will treat personal and customer data as if it were our own, with the same care, attention, and ethical standards. Have a backbone. So upholding these principles is everyone's jobs. If you discover bad practices or have concerns, you have a duty to speak up and highlight areas of concern to the organization. So that's the main three principles in transparency. Now, fairness. Earn trust. Respect the context in which the data is collected, and do not use the data out of our context or in ways that data owner would not expect or have not consented to. Insist on the highest standards. So ensure the data we hold is correct and up to date. So data integrity is paramount here as well. And lastly, respect. So ownership. Remaining accountable for personal and customer data throughout the data lifecycle, from initial collection through storage, processing, and destruction. So that's essentially the data lifecycle. Insist on the highest standards. So what is being done elsewhere in the organization is no bar for our own data handling practices. We will continually raise the bar on data security in line with these principles, in many cases surpassing our legal or regulatory requirements and that asked of information security team. And then lastly is fragility. So by only storing the minimum data that we need for the minimum amount of time, so we limit the impact of information disclosure and further our compliance and regulatory efforts. So that's essentially the backbone of the data principles. So this is the first part of building the DevSecOps framework. In the next video, we'll explore how do we teach developers to quantify and measure the risk. We will delve into continuous integration and continuous delivery tools. But this is the starting point of how we build the DevSecOps frameworks in our organizations. Hopefully you guys, you learned something. Hopefully you guys, you love the video series. Please subscribe, like the videos, and making sure that you subscribe so you can follow the series and get the notification when the part 2 of the video is up and live. Thank you guys.